How you doing?
Good, how are you?
Good. Alright, let's see. I've got this document open. It's been a couple weeks, hasn't it?
I don't think so. I think it's only been one.
Has it really? Okay, I'm going crazy here. Yeah, you're right. We worked on last Monday.
Yeah.
I seem to remember that we had a good breakthrough last time we worked together. We didn't have anything specific to work on. We got a chance to review some just straightforward algebra, and it was very helpful, I thought.
Yeah.
Okay, so I got these documents here. Where do you want to begin?
Just like right here on number 1.
Okay. When they talk about reflecting an image over the x-axis, it's basically, hold on a moment, reflecting a series of points.
Yeah.
In other words, if I had that point right there and I said reflect it over the x-axis, you would know that it had to be 4 units below the x-axis, right?
Yeah.
Well, that's what you're doing here, is you're taking every point and putting it on the other side of the x-axis.
Okay.
And we only have 4 points to worry about. So
Yeah.
in other words, once we translate or reflect those 4 points over the x-axis, then we'll connect the dots and we'll have whatever that quadrilateral is.
Yeah.
Well, Q is 3, they're really going to screw me up here. Q is 6 units above the x-axis, right?
Yeah.
So Q prime has to go 6 units below the x-axis. There is Q prime. P is 8 units above the x-axis.
Okay.
So it needs to be 8 units below the x-axis. So there is P prime. And let's see, we didn't have points on these. Let's assign points to them.
Okay.
Q is 3, oh, man, I hate it when they do this. Q, let's see, that's 2, 4, 6, 8, yeah, okay. So Q is at 4, comma 6. So Q prime is at 4, comma minus 6.
All right.
P was at what?
-2, -8. Wait, yeah.
Minus 2 plus 8, right?
Yeah.
That was P. So P prime must be -2 minus 8.
Yeah.
In other words, all we're doing is changing the sign on the x-coordinate. And how about S? What was the original coordinates on S? Right here.
-4, -4.
Okay, so what are the new coordinates on S prime going to be?
-4 plus 4.
So this is S prime -4 plus 4. And R prime. The coordinates on R are currently what?
That's like kind of in the middle of the box.
Yeah, I would put it exactly in the middle.
All right. So like 4, -6.
Well, what's halfway? In other words, this one is 2, this one is 4, so halfway would be 3.
Yeah.
This one is -6, this one is -8, so halfway in between there is -7.
All right.
So the coordinates on R are 3, -7. Therefore, they would become R prime would be 3 positive 7.
Yeah.
And if we connect the dots, there's our figure reflected over the axis. And notice the slopes are exactly opposite on everything. It's hard to tell that the way I graphed it, but
Yeah.
all right, let's go to 2. All right. So let's draw the first triangle, ABC.
Okay.
Let's see, we're at minus 1, 4. There's point A. And we'll label it minus 1, comma 4. Point B is 2, comma minus 1. And point C is 4, comma 3. So there's the triangle.
All right.
And they want us to transform the image with the following translation and rotation. Well, so we have two things we're going to do. We're going to translate every x coordinate. We're going to move it 2 units to the right. Every y coordinate, we're going to move 1 unit down.
All right.
Then after that, we're going to reflect it across the line x equal minus 2.
Okay.
So let's do the first step.
So x up to y minus 1.
Okay, so where's A prime?
Minus 2, 6.
Okay, A is minus 1, comma 4.
Yeah.
So we're going to add 2 to the y coordinate, and we're going to subtract 1 from the, we're going to add 2 to the x coordinate.
Yeah.
So what's minus 1 plus 2?
Plus 1.
Okay, and then we're going to subtract 1 from the y coordinate.
3.
Okay, so we need to plot plus 1, comma 3.
Yeah.
Plus 1, comma 3. That puts it right there. So I'm going to call that A prime. And that's going to be plus 1, comma 3. Okay, what is B prime?
So 6, 2.
Okay, what is B?
B is... Oh, wow. I'm dumb.
What's B prime?
Alright, B is 4, 0.
What's minus 1 minus another 1?
Minus 2.
Okay, that's what... Remember that here is B. So the new B, B prime, has to be 2 units to the right and 1 unit down from that old B. Because that's what we're doing, is that translation. So if I move 2 units to the right and 1 unit down, here's my new B right here. And that's B prime. And it is 4, comma, hold on, do this again. 2 units to the right. Oh yeah, that's correct. Okay, 2 units to the right and 1 down. Okay, I was correct. I was just thinking about it wrong. And that was B4, comma minus 2. And finally, C prime.
6, 1.
Okay, so 6, 1. How about 6, 2?
6, 2.
Yeah, we're adding 2 to the x, we're subtracting 1 from the y.
Okay.
See how it's 6, 2?
Yeah.
Okay, and that is right there. So we'll call that C prime, and that is 6, comma 2. Okay, so there's our A prime, B prime, C prime after just the translation. Now let's reflect those about the line x equal minus 2. Well, let's go over here and find x equal minus 2. And they said about the line. So I'm going to draw a dotted line right there like that. And I have to reflect A prime, B prime, and C prime about that line.
All right.
So A prime, let's deal with it first. In fact, I am going to erase the original triangle I had here, just because it's confusing the issue, and the original C, and the original B, so that the only 3 points I have are the 3 vertices that have been translated.
Okay, but do you need to use the original triangle over again?
No.
All right.
In other words, I'm going to do this in 2 steps. We did the first step, which was to translate the original 3 points.
Yeah.
Now we're going to do the next step, which is to reflect those translated points about this line.
Okay.
So what is A, we'll call it A double prime.
All right.
So somewhere over here, in fact, nah, that's not going to work, is it? We'll just have to make do. Somewhere over here, what are my coordinates of A double prime?
So you're trying to, what are you trying to do with the -2? From the
In other words, the very first question we did was reflect this over the x-axis.
Yeah.
Okay, that is a reflection over the line y equals 0.
Yeah.
So this is reflected over the line x equal minus 2, which is a vertical line that goes through the point minus 2. Okay, so that's what this dotted line is that's x equal minus 2.
Okay.
So if I want to reflect A prime over that line, that means it has to end up as far away from that dotted line as it currently is.
Okay.
How far away is it from the dotted line, the x-coordinate of A prime?
4.
It's 3, isn't it? In other words, it's 2 to get to there, and then 1 more to get to there.
Yeah.
So we need it to be 3 units to the left of the dotted line. So what's my x-coordinate on A double prime?
Wait, 3 is the x?
No.
3 is the y?
1 is the x.
Alright.
3 is the y. And 3 isn't going to change. In other words, when we reflect this about this vertical line, we're going to have the same y-coordinate. The only
so is it -2?
No, -2 is right here.
Okay.
So I got to be 3 units. In other words, 1 is 3 units away from -2.
Yeah.
So we got to end up 3 units on the other side of this dotted line.
Okay.
Well, that dotted line is at -2, so the new x-coordinate is -5.
Oh, okay.
The new y-coordinate is 3.
Alright.
What all that stuff that I was writing. There it was. Okay, so graphically speaking, I'm not going to be able to make this look right.
Yeah.
Because I didn't draw it far enough in the center of my page.
Yeah.
And it doesn't do any good to expand it. I still don't have enough room. However, it doesn't prevent you from telling me what the C double prime would be. C double prime is going to end up way over there.
Okay.
What is its x-coordinate going to be?
-8.
How far is C prime from that dotted line?
8.
So how far does it have to be to the left of the dotted line?
More than 8?
No, exactly 8.
Oh, 8.
So what does that give it as an x-coordinate? If this dotted line is at -2,
Yeah.
I have to be 8 units left.
-10?
Yeah.
Oh, okay. Alright, yeah, I get this
And the
now.
y-coordinate?
2.
Got it. Okay, let's do B. B prime is going to be somewhere here. B double prime, excuse me. What's the x-coordinate? We know the y-coordinate is going to be -2 on B double prime.
Yeah.
What's the x-coordinate?
So I have to get to the dotted line, I have to go 6.
Okay, good.
And so, is it 8?
Plus or minus?
-8.
Yeah. In other words, you go 6 more.
Yeah.
So there are our 3 translated and rotated points.
Yeah.
Now, does it matter whether you translate first or rotate first?
You have to rotate first.
Yeah, you do. And I didn't.
Oh, really?
But in this case, let me think about that for a moment. Might have done this backwards, and I do think it matters. Let's try an experiment here. If I take a right triangle and I want to reflect that about the y-axis, it ends up being there, correct? You with me here? I'm doing an experiment to tell whether or not we did this problem right.
Okay.
Okay? Now, this is a straight reflection over the y-axis.
Yeah.
If I said, let's move this triangle down 1 and to the right 1, and then reflect it, I get that.
Okay.
If I reflect first and then move it down 1 and to the right 1, I get this. So it does matter which you do first.
Okay.
Now, the only thing that I'm truly puzzled by is why they list these in reverse order. Because it sure seems like they want us to do the translation first.
Okay.
They don't even call it a reflection, they call it a rotation. You don't have answers on these, do you?
No, this is like the pre-test. No, it's like the study for the test.
Well, I know that when you are dealing with functions, hold on a minute. Yeah. In other words, if I say y equal minus x squared,
yeah,
that is a reflection over the x-axis. So
yeah.
there's y equal x squared. There is y equal minus x squared.
Okay.
And if I say y equal minus x squared plus 2, the order that I do these in is important, because if I do the reflection first and then the vertical shift, it moves it up to there.
Yeah.
If I do the vertical shift first and then the reflection, well, the vertical shift would move it up to there, and then when I do the reflection, it's down to there, so I have a totally different answer. So when you're dealing with functions, you always do your reflections first. It makes a difference. And it doesn't, if you have a reflection over the x-axis and the y-axis, it doesn't matter which reflection you do first.
Yeah.
But you want to do any reflections that you're going to do first, not after you've done the translations.
Okay.
Now, boy, does that apply to when you have a triangle that you are translating and rotating. I would be inclined to say that it does, and that I probably did this problem backwards. In other words, I think the first step would be to reflect over the line x equal minus 2.
Yeah.
Come up with a prime, b prime, and c prime, and then apply the translation where you add 2 to the x-coordinate, subtract 1 from the y-coordinate to come up with a double prime, b double prime, and c double prime.
Yeah.
I believe that's the proper way to do it. I'm a little puzzled that they didn't list the reflection first and the translation second, since that's the order that they're supposed to be done in. But I'm not 100% sure of that either. In other words, it's not going to surprise me terribly if you go to class and find out they did the translation first and the reflection second.
All right.
Only because we're not dealing with a function here, we're dealing with 3 points. And I'm not sure those same rules that apply to translating functions apply to this situation.
All right.
So let's go on rather than spend our whole session on it.
Yeah.
So write an equation of the line passing through that point that is perpendicular to the given line. What is the slope of the given line?
13.
No. If y equals mx plus b and m is the slope.
Yeah. Minus 3.
Minus 3?
Yeah.
What is the slope of the perpendicular line to that?
Positive 3?
Remember, perpendicular is the what?
The opposite?
The negative reciprocal.
Oh, yeah.
2 words, meaning there's 2 actions needed. So what's the reciprocal of 3?
1/3.
And what's the opposite of negative?
Positive.
So the slope of our perpendicular line is plus 1/3.
Okay.
Okay. Now we have a slope, and we have a point.
Yeah.
What's the equation of our line?
Y equals 1/3 x plus 13.
No, plus b. We don't know what b is yet.
Right.
How can we solve for b? We know that this equation goes through that same point.
Yeah.
So this, whatever this equation is, has to satisfy that point. In other words, when I substitute 10 for y and 6 for x, that will allow me to solve for b.
Okay. So yeah, 10 equals 1/3 times 6 plus b.
And then what does b equal?
So 1/3 times 6
Is what?
is,
One,
is it?
1/3
Yeah.
times 6 over 1. We're
Yeah.
multiplying, so we're going to multiply numerators and denominators. But rather than multiplying, let's simplify first.
Alright.
Divide top and bottom by 3.
Okay.
So now we end up with 2 over 1.
Yeah.
Okay? So now what is b? If 1/3 times 6 is 2.
Yeah. So I got a -2. 8.
Okay. So what's the equation we're looking for?
Y equals 1/3 plus 8.
Right. 1 over 3x plus 8.
1/3. Yeah.
In other words, your final equation always has to have both the y and the x.
Okay.
And not always. In other words, it could be a vertical line or a horizontal line, which would only have one of the two. Okay? So that's the way we're going to do it. In other words, we're going to find the slope of the perpendicular, and then we're going to use y equal mx plus b and solve for b. All of these problems. So, what's the slope of this equation?
It's -1/3.
What is the slope of the perpendicular?
+3.
What's the amount of the equation that we know at this point?
Y equals 3x plus b.
And the point that it goes through?
0 equals...
No, make sure you plug in the correct value for the correct variable.
-8
Okay.
equals 3 times 0 x minus b. Plus b.
Yeah, it's 3 times 0, though. It's not 3 times 0x. In other words, what we're doing is we're plugging in 0 for x.
Yeah.
And we're plugging in -8 for y.
Okay.
So what's b equal to?
-8?
Correct. So our equation is we're just going to erase that and put in -8. So that's our answer.
Alright.
Okay, parallel. Very similar. What's the slope of this line?
Wait. For parallel, you don't have to flip it or do the negative reciprocal.
First of all, what's the slope of this line here?
Is it just 4?
So what's the slope of the parallel line?
4.
Okay.
Alright.
But it has to pass through this point. So what should I write next?
3 equals 4 times -1 minus b, or plus b.
Plus b, because we don't know if it's going to be plus or minus yet. In other words, this -7 is irrelevant.
Okay.
Okay, so all we know is that we have a line that has a slope of 4, and it passes through the point -1, 3.
Yeah.
So what's b equal to?
7.
So what's my equation?
Y equals 4x plus 7.
Okay. And the next one, 6. What's the slope of that line?
-6.
And what's the slope of the parallel line?
-6.
And what's the equation that we can start?
Y equals -6x plus b.
Yeah, I think it's a good thing to write that step. In other words, we kind of bypassed it with the last problem. We filled in the y and the x immediately. but
Yeah.
it's helpful if you actually write this step. So what next?
You gotta plug in the points. So minus 3 equals minus 6 times 2 plus b.
Okay. Solve for b.
Um, b is positive 9.
Good. So I'll just go back and erase that and put in a 9, and there's my answer. All right. All right. I'm getting a little geometry finally again. I haven't been doing much geometry.
Yeah.
Okay. So what makes that quadrilateral a parallelogram? What would have to be true if it was a parallelogram for number 7?
They would have to be congruent, the sides.
These two measurements that they're pointing to would have to be congruent, which means the same.
Yeah.
So what can I write? What equation can I write?
7x plus 1 plus 8x minus 10.
If this has to be equal to that,
Yeah.
then we want to say it's equal to 8x minus.
Oh, okay. Yeah.
Okay? In other words, this side, this length right here, has to be the same as that length if it's a parallelogram. If it was not a parallelogram, it wouldn't have to be.
Okay.
But if this is equal to that, and they're telling us that it is, then as long as this is equal to that, we have a parallelogram.
Yeah.
So let's solve this equation.
So you combine like terms?
Okay.
Alright, so should we do the x's or just the numbers first?
Let's do the x's first.
Alright, so let's go minus 8x.
Okay, let me suggest a different method.
Okay.
Let's do minus 7x.
Alright.
Why? Why would I say that?
Because so it's not negative?
Exactly. In other words, if I move this 7x to the right, I'm going to end up with a positive x.
Yeah.
If I move the 8x to the left, I'm going to end up with a negative x.
Yeah.
Okay? So let's move the 7x to the right, which means we want to move the minus 10 to the left.
Yeah.
Bingo, one step.
Okay.
So as long as x is equal to 11, that is a parallelogram.
Okay.
Okay? What makes this a parallelogram? What has to be true? See if you can figure it out by looking at it.
Okay.
What has to be true about this angle and this angle? The two angles on the left that are defined by 2x plus 5 and 3x. Hold on one second while you're thinking about that. Hello? I am. That's okay. Well, that's okay. What I can... Okay. Mm-hmm. Okay. Okay, I don't. It's at Colorado City? Oh, okay. Let me go ahead and call you back and I can get the directions and everything. Okay. Okay, sounds good, Jackie. Okay. Okay, okay. Sorry about that, Julian. I was kind of waiting for that phone call.
That's
I wasn't sure what I was doing for Thanksgiving this year.
no,
So,
that's
if we have a parallelogram, let's make
yeah.
some various parallelograms.
Okay.
What do you suppose is true about angle 1 and angle 2?
They're parallel.
No.
No, they're congruent.
Do they look congruent? One is acute, one is obtuse.
No, then.
Okay, let's look again at angle 1 and angle 3. What would be true if that was a parallelogram?
They are, I don't,
Equal.
equal.
Angle 1 and angle 3. In other words, opposite angles are equal in parallelograms.
Yeah.
1 is equal to 3 and 2 is equal to 4.
Okay.
Okay? And even if I make my parallelogram a rectangle, that's true.
Yeah.
Okay? But if 1 is equal to 3 and 2 is equal to 4 and all four of them add up to 360,
Yeah.
then what must be true about 1 combined with 2?
Like I don't know how to say it, but like
What would they add up to?
180
Yeah, that means they're supplementary.
supplementary. Yeah.
And in any parallelogram, any consecutive angles are always supplementary. 1 is
Okay.
supplementary with 2, 2 is supplementary with 3, 3 is supplementary with 4, and 4 is supplementary with 1.
Okay.
So any consecutive angles have to be supplementary. So what can I say about this parallelogram? What would have to be true? 3x plus 2x plus 5 would have to equal,
180.
okay, solve that.
Alright, 5x plus 5 equals 180. 175. Oh, so you just minus 5? Okay.
I just did it in one step instead of two.
Okay.
And then x is equal to
So, 35. Okay.
and that's all they wanted was the value of x. In other words, this angle here is 105 degrees and it looks like it. In other words, whenever you're doing geometry, always eyeball to make sure. If we came up with a value of x of 10, then that would say, well, this angle is 30 degrees. Well, that would be impossible. That doesn't look like a 30-degree angle. I can tell that it's greater than 90.
Yeah.
So coming up with an x of 35 is just right because it makes that angle 105 degrees. It makes this angle 75 degrees. And that also looks right. So the two things that these two problems tell us is that when you have a parallelogram, the diagonals bisect one another and consecutive angles are supplementary. And opposite sides are equal. In other words, in both of these parallelograms, you'll notice this side is equal to this side and this side is equal to that side. They don't state that, but it's true. All right. Let's see here. Let's do these one at a time. What time did we start? 4:30?
Yeah.
Okay. It says graph the quadrilateral in the coordinate plane and classify it, and then find the perimeter of the image. Okay. I'm going to approximate the 4 points. -4 minus 2. let's put that right there. That's A. B is minus 2, 1. C is 4, comma 1. And D is 2, comma minus 2.
Okay.
Now, notice that they have given us a figure that everything is horizontal
Yeah.
or has a slope, looks like a parallelogram.
Yeah.
So, what makes that a parallelogram? How do we know if that's a parallelogram?
Because all the sides equal 360.
First of all, the angles would have to equal 360, but that wouldn't make it a parallelogram. In other words, any quadrilateral, that's true. If I draw a quadrilateral like that, the sum of all the angles is 360. It's still not a parallelogram.
Yeah.
What makes it a parallelogram, we just discovered from the previous question, is that side, opposite sides have to be equal.
Okay.
Okay? They don't, all four sides don't have to be equal. That would make it a rhombus. But for a parallelogram, you merely need to have the opposite sides equal and parallel to one another. Well, I can certainly see that this side is parallel to this side. They're both horizontal lines.
Yeah.
And this side here looks like it's parallel to this side here. How can I tell if they're parallel or not? I know the top side is parallel with the bottom, but how about those two slanted sides? What would make those parallel?
If they were supplementary?
Oh, what makes, let's go back to the earlier questions. When you have a line that is parallel to another line, what is true about those two lines? What's true about their slopes?
They
have to be the same.
Like having the opposite slope?
They have to be the same. Parallel lines have the same slope.
Okay.
Perpendicular lines have negative reciprocal slopes.
Yeah.
But if I'm trying to prove that this line is, if AB is parallel with CD, then all we need to figure out is the slope. I already know that BC is parallel with AD, because they're both horizontal. But I can't know for sure if AB is parallel with CD until I look at their slopes. Well, what's the slope on AB?
The slope is -2.
Hold on. It's the difference in the y's.
Yeah.
Divided by the difference in the x's.
Yeah.
So what's the difference in the y's?
3.
What's the difference in the x's?
2.
Okay, so the slope is 3/2. You can look at it. Is it a positive slope or a negative slope?
Positive.
Okay, so the slope is positive 3/2. Now let's go look at the slope of CD.
Okay.
What's the difference in the y's?
3.
What's the difference in the x's?
2.
And we can see that it's positive, so that's also 3/2. So they do have the same slopes. Therefore, parallel, 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 that's really what defines a parallelogram.
Yeah.
Other properties that I mentioned are properties of a parallelogram. In other words, not only are the opposite sides parallel, but they're equal. Not all four of them, but that side's got to be equal to that side, and that side's got to be equal to that side.
Yeah.
So we need to figure out the distance because the next question says find the perimeter.
Okay.
Well, it's easy enough to find the distance from B to C.
Yeah.
And from A to D.
Yeah.
But finding the distance from B to A requires me to apply the distance between 2 points formula.
All right.
So what's the distance from A to B? Same as B to A.
Wait. So it's the same. What?
Well, it doesn't matter whether we're talking A to B or B to A.
Yeah.
All I'm looking for is an absolute value, a distance from this point to that point.
Okay.
And I need the distance formula.
Yeah.
Well, distance, it's always the hypotenuse of a right triangle.
Okay.
In other words, if I want to remember the distance between 2 points on the XY coordinate plane,
yeah.
the way to think about it is let's take those 2 points and turn it into a triangle.
Okay.
Well, those 2 points now represent the hypotenuse of that triangle.
Yeah.
So we're going to use the Pythagorean Theorem.
All right.
Well, the Pythagorean Theorem says that the hypotenuse of a triangle is the square root of the sum of its sides. Well, this side here is the difference in the x-coordinates squared. That would be 2 squared. And this side here is the difference in the y-coordinates, and that would be 3 squared.
Okay.
So the distance between those 2 points is the square root of 13.
All right.
So I've got square root of 13 there. So now to really determine whether we have a parallelogram or not, no, we know we have a parallelogram because we've got 4 slopes. In other words, the opposite sides of this thing each have the same slope. So that makes it a parallelogram. And in fact, I don't need to use the distance formula over here because it's a parallelogram. I know this has to be root 13 also. What's the distance from B to C? We don't need the distance formula on this because it's a horizontal line. Hold on, let me go turn my TV down. It came on by itself. Hold on. All right. So what's the distance from B to C?
6.
Good. And what's the distance from A to D?
6.
So what's the perimeter of our parallelogram?
So since that's square root 13, like how would I add that to?
Okay, so I've got 6 plus root 13 plus root 13. Well, that's 12 plus 2 root 13s.
Yeah.
That's the answer.
All right. Okay.
Now, unless she wants you to convert that to a decimal, and I hope...
I'm not.
Yeah, no, this is the most accurate answer. This is the correct mathematical answer.
So, can you like refresh me on how you got that root 13?
Yeah. Look at this right here.
Yeah.
That triangle with the dotted line.
Okay.
Notice that the side AB is the hypotenuse of that triangle.
Yeah.
Okay. Well, you actually might not have covered this yet. Let's talk about right triangles. Because you don't really cover the Pythagorean Theorem until you get to geometry, but this is perhaps the most important theorem in all of geometry. And what it says is that if you have a right triangle, the hypotenuse squared is equal to the sum of the sides squared.
Okay.
Okay, that is the Pythagorean theorem in a nutshell.
Alright.
Okay, c squared equals a squared plus b squared. So, if I'm trying to solve for the hypotenuse, c, then I've got to take the square root of both sides. So it's now the square root of a squared plus b squared.
Okay.
Now, in our triangle, that's exactly what we're solving for, is the hypotenuse. And we know this side here is the distance from -4 to -2, so that's 2.
Okay.
This vertical distance is the distance from 1 to -2, so that's 3.
Okay.
So now I have a triangle that I'm solving that has sides of 2 and 3.
So 2 squared plus 3 squared?
Yeah, the square root of that. In other words, this side is 2, that side is 3. So this side here squared has to equal the sides of this square. In other words, if I make this square root of 13, now c squared is equal to a squared plus b squared.
Okay.
Okay? So whenever you're solving, let's practice that, because there's just almost nothing that you want to be able to do better than solving right triangles. Solving right triangles is going to be something that you're going to have to do for years to come.
Alright.
When you take your ACT test, there's going to be like 20% of the problems are going to be solving right triangles. So let's practice some right triangle solutions. If I'm going to give you 2 sides of a right triangle, and I want you to figure out the third side.
Alright. Alright,
So first of all, it's worth noting, don't always go back to the Pythagorean theorem, only because it slows you down. Let's solve for c. c is the square root of a squared plus b squared. So go ahead and solve for c on my triangle that I've drawn here.
So 3 squared plus 4 squared equals c squared?
Well, more importantly, start with c. Start with this.
Alright, so c equals 3
Don't always go back to the Pythagorean theorem. If you always go back to this, then you got to solve that for c. But remember this definition of c.
Alright.
So in our case here, c would be the square root of 3 squared plus 4 squared.
Yeah.
It's the square root of 25. That's
5.
5.
Okay.
That's because it's a 3, 4, 5 triangle. Okay.
Yeah.
So solving for the hypotenuse is generally fairly easy. You always use this formula right here.
Yeah.
Now let's solve for one of the sides.
Okay.
In other words, they're going to give you 2 pieces of information every time they want you to solve a right triangle. When I say they, I mean all your math teachers for the next 4 years. Okay? So sometimes they will give you the hypotenuse and one side, which means I'm always solving for one of these sides here. So if I move one of the sides to the other side, I get a is equal to the square root of c squared minus b squared. Or if I'm solving for b, it's the square root of c squared minus a squared. Okay?
Yeah.
So you really only have to remember 2 formulas. You don't have to remember both of these. Look, they look exactly the same, right? When you're solving for one of the short legs of a right triangle, it's always the square root of the hypotenuse squared minus the other side squared.
Okay.
So let's solve for x.
Alright. So 12 equals...
No, hold on. x equals.
X
In
equals.
other words, we're going to use one of these.
Okay.
Because we have the hypotenuse and we have one of the short sides.
Yeah.
We're solving for the other side.
Alright.
So always remember when you're solving a right triangle that your
If
answer
I'm solving for A and C, it's the same as...
Well, notice that both of these look the same because both of these we're solving for the short side and it's the square root of the hypotenuse squared minus the other side squared.
Yeah.
So this equation is basically the same as that equation. Both of them are used to solve for the short side of a right triangle. Well, that's what we have here is the short side of a right triangle. So it's x is the square root of what? And remember, your answer always must start out square root of. Notice that no matter what I'm solving for, all three of them are square root of something.
Yeah.
So if you start your answer out with anything other than square root of, you're making a mistake. So x is the square root of what?
12 squared.
Start with the hypotenuse. Always has to be the hypotenuse in front. Because the hypotenuse is the longest side of that triangle.
Yeah.
If I put 12 squared minus 13 squared, I'm going to end up with the square root of a negative number.
Yeah.
So it's got to be 13 squared minus 12 squared.
Okay.
Okay? Well, that is 169 minus 144. Well, that's also square root of 25, which is 5.
Okay.
And that is why that is a 5, 12, 13 triangle. Okay. We've got 3 minutes. Let me just give you some right triangles and have you solve them. Like I said, you can't get too much practice. What's x?
Alright, so x equals 6, the square root of 6 squared minus 4 squared.
It's 36 minus 16. That's the square root of 20. Simplify that.
The square root of 20.
Uh-huh.
4?
No. In other words, it's an irrational number.
Yeah.
Because it's not a perfect square number.
Yeah.
The way I'm going to simplify it is I'm looking for factors of 20 where one of them is a perfect square. Well, 4. In other words, that's the square root of 4 times the square root of 5. That's what the square root of 20 is equal to. Well, the square root of 4 can be turned into a whole number 2.
Okay.
So that's really the square root of 20.
Alright.
It's 2 root 5.
Okay.
Okay? Solve for x.
Alright, so x equals the square root of 7 minus the square root of 3.
7 squared. Remember, everything inside the radical has to be squared.
Yeah. So 49 minus 9, so x equals 40?
Square root of 40.
Square root of 40.
Which can be simplified, but let's not do that right now because I want to practice more. What's x?
So c equals, or x equals the square root of, now it doesn't matter which one I put first?
You're right, because I'm going to add them.
Yeah.
In other words, whenever you're solving for the hypotenuse, you're always adding inside the radical.
Yeah. So 2 squared plus 1 squared?
Yes. Square root of 5.
Yeah.
And that's really the only 2 problems you're ever going to be faced with in solving a right triangle, is where you have to either solve for the hypotenuse or you have to solve for one of the short sides.
Okay.
And it doesn't matter which side you're solving for.
Yeah.
you're going to use the same formula. In other words, it doesn't matter whether I'm solving for that or solving for that. The formula is going to be the square root of the hypotenuse squared minus the other side squared.
Yeah.
So there's only two formulas you really have to remember for solving a right triangle. And we just did it, and you did good on it. So remember that, because that is definitely a big skill for math, is being able to solve any right triangle. And you can do that now. So I will let you go, and let's see. Next week you don't have anything scheduled. It's Thanksgiving.
Yeah. I don't have school all of next week.
Okay. I imagine your mom will probably schedule something for the week after.
Yeah.
All right. I'll let her do that.
All right.
Okay. Have a good Thanksgiving, Julian, and I'll talk to you after the holiday.
All right. Thank you.